2016, paper 22. March 2016, paper 22. Okay, so question number 1 says, the question is about period 3 elements and their compounds. Give an explanation for each of the following statements. The atomic radius decreases across period 3. So you have to just give an explanation. Why does the atomic radius decrease across period 3? Anyone? Why does the atomic radius decrease across period 3? So what happens across period 3? So the number of shells remains the same. Number of shells remains the same, right? But there's an increase in nuclear charge, right? So across the period, right? The number of the nuclear charge increases, right? However, the number of shells remains the same. Right? Hence, outer electrons are experience more attraction, experience greater attraction or greater attractive force, right? Greater attraction from nucleus, right? So they're more tightly held, which means that the atomic radius decreases. All right, the first ionization energy of sulfur is lower than that of phosphorus. So does anyone remember sulfur and phosphorus mein kya hota tha? Sulfur and phosphorus mein, does anyone remember the configuration? Sulfur was P4 and phosphorus was P3. So why is sulfur lesser? Normally the बढ़ती है across the period, but phosphorus to sulfur, exactly. P4 में क्या होता है? If you guys remember, sulfur is P4, so it has a paired electron, right? And phosphorus के सारे क्या होते हैं? Unpaired होते हैं, right? So we can say that, right? We can say that one of the 3p orbitals in sulfur has paired electrons, making the electron easier to remove. Right? Due to mutual repulsion. Due to mutual repulsion, the electrons repel each other, so it's easier to remove. Okay. Okay. Why is sodium a better electrical conductor? Yes, that's correct, Mohammed. Yeah. Sodium is a better electrical conductor than phosphorus. Okay. What type of bonding does sodium has? It's a metal, right? So sodium has what? Sodium has metallic bonding. Hence it has what? Has delocalized electrons. Delocalized, yes, or free electrons. Free electrons that are mobile and carry charge and can conduct electricity, right? And this is because sodium में क्या होती है? Metallic bonding. I'll write that down parentheses, right? Phosphorus, on the other hand, phosphorus क्या होता है? What type of a structure is phosphorus? Anyone remember? Is a simple molecular structure. Okay. And therefore does not conduct electricity. Hence does not conduct. All right. Magnesium is a better electrical conductor than sodium. So what's the difference between magnesium and sodium? Magnesium simply has more electrons, right? That it releases in the metallic lattice. Outer shell में दो electron होते हैं, so it releases both of them in the metallic lattice, right? So the only difference is that magnesium has two electrons per atom that can conduct electricity versus one from sodium. Has two free electrons or delocalized electrons per atom versus one from sodium. So simply has more electrons, therefore it conducts more. Okay. All right. The flowchart below shows a series of reactions. Give the formula of each of the compounds A to D. Yeah, outer shell electrons metallic lattice में free हो जाते हैं ना. So obviously it has more electrons that it releases into the lattice, so it can conduct more electricity. Right? Yeah. Now part B says, okay, so give the formula of each of the compounds A to D. Okay, when magnesium reacts with nitric acid, what does it form? Reactive metal with an acid. So it will form salt and hydrogen gas. So A is the aqueous salt, so that's magnesium nitrate. Mg is 2 plus, NO3 is 1 minus. So we need two nitrates, magnesium nitrate. And what's the gas that's produced? Hydrogen gas, right? And then C के अंदर क्या करें? They're heating the magnesium nitrate. They're heating the magnesium nitrate. Okay, so the nitrate is decomposing. It's hydrated, it's aqueous, so पानी भी निकल रहा है, ऑक्साइड भी निकल रहा है. और क्या निकलता है जब नाइट्रेट को हीट करते हैं? What gases are released? Nitrogen dioxide and oxygen gas. It doesn't matter which order you write them. C or D. All right, they're saying that E reacts with dilute aqueous acid to produce a gas that turns lime water cloudy. So then what type of a solid is E? It produces carbon dioxide with acid. So what type of a solid is it? This gas that it produces when it reacts with acid is carbon dioxide. So it's a carbonate. So it must be magnesium carbonate. So then what reagent can I use to convert magnesium nitrate to magnesium carbonate? What reagent can I use to convert magnesium nitrate to magnesium carbonate? I'm going to need some carbonate, but it has to be a soluble carbonate. It has to be a soluble carbonate, not calcium carbonate. भाई देखें, हम लोग ये चाह रहे हैं कि ये एक्वस रिएजेंट हमने डाला, सही है, इसमें कार्बोनेट आयन भी होगा, इसमें मैग्नीशियम आयंस ऑब्वियसली होंगे और नाइट्रेट आयंस होंगे, वो तो ए से आ रहा है, राइट? ए से मैग्नीशियम और नाइट्रेट आ रहा है और हम चाहते हैं कार्बोनेट आए तो प्रेसिपिटेट बन जाए. सो वी नीड सम सॉर्ट ऑफ सॉल्युबल कार्बोनेट सॉल्ट. So you can use sodium carbonate, you can use potassium carbonate, you can use ammonium carbonate, any soluble carbonate salt. But which cation की सारी salts हमेशा soluble होती हैं? कौन से cation की सारी salts soluble होती हैं? किसी को याद है? Anyone remember? The easiest answer here, potassium. All potassium salts are considered soluble. So you can just say, and sodium carbonate would also be correct here, by the way. So we can just say potassium carbonate. You can also say sodium carbonate since it is soluble. All right. Sodium carbonate, ammonium carbonate, and so on. But we'll just stick to potassium carbonate since we know that all potassium salts are soluble. All right. Spathos is an iron ore that contains iron 2 carbonate. The percentage of iron 2 carbonate in spathos can be determined by titration with acidified potassium dichromate 6. using a suitable indicator. The ionic equation is shown below. So what we have is we have a 5-gram sample of spathos, which is impure iron carbonate, iron 2 carbonate, and we react it with excess concentrated hydrochloric acid, right? And then filter it. The filtrate was made up to 250 cm cube, a 25 cm cube. So what we did was हम लोगों ने हमने कार्बोनेट लिया, सही है, हमने उसको रिएक्ट किया एसिड के साथ, एक्सेस एसिड के साथ, एसिड वाज लेफ्ट ओवर, उस बाकी लेफ्ट ओवर एसिड से हमने 250 cm क्यूब सोल्यूशन बनाया और उस 250 cm क्यूब सोल्यूशन में से हमने 25 cm क्यूब लिए and we reacted it with dichromate. So this reaction is the one given to us. This reaction over here is the one given to us in the equation, right? So now my question is, first of all, first question is simple. The amount in moles of dichromate used in the titrations. So this is the amount of dichromate that we've used, right? So we can just say N is equal to CV. ये तो straightforward है. 25 cm cube के साथ कितने dichromate ने react किया? We had 0.02 mole per dm cube, and we had 27.3 centimeter cube. So what does that come out to? What do that come out to? Anybody? We have 5.46 times 10 to the power of minus 4 moles. Okay. Now they're saying use your answer to part 1 to calculate the amount in moles of Fe2 plus present in the 25 cm cube sample. तो वो कह रहे हैं इस सैंपल में आपको पता है आपने डाइक्रोमेट कितना यूज किया, तो आयरन 2 प्लस कितना था, इक्वेशन हमें दिया हुआ है. So we have a ratio of 1:6, right? We know that for every 1 mole of chromate we needed 6 moles of iron 2 plus. So if I have 5.46 times 10 to the power of minus 4, how many moles of Fe2 plus do I have? So that's just 6 times number of moles of Fe2 plus is just equal to 6 times 5.46 times 10 to the power of minus 4. So what does that come out to?
It's 3.276 into 10 to the power minus 3.
Okay, so 3.28 times 10 to the power of minus 3 moles, right? Or 3.276. So we'll use 3.276 in our working, but okay. So now we figured out कि आयरन हमारे पास कितना प्रेजेंट था. अच्छा मुझे ये बताएं कि पहले रिएक्शन में हाइड्रोक्लोरिक एसिड के साथ आयरन ने रिएक्ट किया था या नहीं किया था, या सिर्फ कार्बोनेट ने किया था? पहले रिएक्ट, ये तो दूसरा रिएक्शन है, राइट? दूसरे रिएक्शन में ये हो रहा है, डाइक्रोमेट के साथ रिएक्ट कर रहा है. पहले रिएक्शन में HCl के साथ सिर्फ कार्बोनेट ने रिएक्ट किया था, राइट? सो जितना भी आयरन है सारा आयरन बेसिकली लेफ्ट ओवर था. सो नाउ वी नो कि 25 cm क्यूब में हमारे पास इतना आयरन है, तो 250 cm क्यूब में कितना आयरन था? तो अगर 25 cm क्यूब में हमारे पास है 3.28 times 10 to the power of minus 3, तो 250 cm क्यूब में कितना था? We just had 10 times as much.
So 3.28 into 10 to the power minus 2.
Exactly. So this is just 10 times as much, which implies that number is equal to 3.28 times 10 to the power of minus 2. Good. So that's how many moles we had of iron 2 plus in the 250 cm cube solution. So can I say that I know that iron 2 carbonate का formula is FeCO3, and if I know, हमें पता है कि Fe2 plus के हमारे पास total moles कितने थे? 3.28 times 10 to the power of minus 2. So can I say that the number of moles of iron 2 carbonate were the same? क्योंकि भाई अगर आपको पता है कि कार्बोनेट के 1 मोल से आयरन का 1 मोल आता है, आपको पता है कि कार्बोनेट आपको पता है कि Fe2 plus और FeCO3 का रेशियो 1:1 है. So आपके पास जितना भी iron 2 plus था उतना ही iron 2 carbonate होगा, right? So this is the number of moles of iron 2 carbonate that I have. So then what's the mass of iron 2 carbonate? The question is asking for the mass of iron 2 carbonate. So can I say that the number of moles is equal to mass over molar mass, which implies that the mass is just 3.28 times 10 to the power of minus 2 times the molar mass. What's the molar mass of iron 2 carbonate? Go to the periodic table. Or have they given it to us? They haven't given it to us, so we have to find it. So iron का mass होता है 55.8. So we have 55.8 times 2 plus carbonate is 12 for carbon and 16 times 3 for oxygen. So what does this mass come out to? What does M come out to over here? Yeah, sorry, my bad. No, it's iron is just 1 over here. That's my mistake. Yeah, iron times 1. So क्या mass आ रहे हैं यहाँ पर? 1 Fe, yes, 1 Fe, 1 Fe. So what does this mass come out to? 79 आ रहा है. अच्छा. So 3.79 grams. So mass is equal to 3.79 grams. Okay. Yeah, so we have 3.79 grams of iron carbonate, iron 2 carbonate. So what's the percentage? We had a 5 gram sample. So our percentage purity is just the mass that we got divided by the total mass, right? Which is equal to 3.79 divided by 5 times 100. So what does that come out to? 75.87. So that's 75.9%. So that's your percentage purity of iron carbonate in the Spathos sample, or percentage by mass of iron carbonate, iron 2 carbonate. Okay. All right, next question. Or next part. Iron ores containing iron 3 compounds can be analyzed using a similar method. A standard solution of an aqueous iron 3 compound is reacted with aqueous tin 2 chloride. 75.9, yes. So a standard solution of iron 3 compound is reacted with aqueous tin 2 chloride. Aqueous tin 2 chloride से हमारा बनता है aqueous tin 4 chloride and iron 2 chloride are the products. Write an ionic equation for this reaction. So what species are reacting? I've highlighted them. Iron 3 is reacting with tin 2. Iron 3 is reacting with tin 2 to form iron 2 plus and tin 4 plus. So अब अगर आप देखें तो tin जो है +2 से बड़ा है, iron -1 से कम हो रहा है. So how many irons do I need for every 10? How many irons do I need for every 10 over here? I'm going to need 2 of them, right? And you can balance this using half equations as well if you'd like. We know that iron is undergoing reduction to form Fe2 plus, and tin is undergoing oxidation and it's losing 2 electrons. So then we're going to multiply the upper equation by 2. And that we get this overall equation if we add the 2 equations up. Okay. The electrons will cancel out. All right. Any excess tin 2 chloride can be removed by the reaction with HgCl2. A white precipitate of Hg2Cl2 is produced. Complete the equation for this reaction. Okay. So tin 2 chloride का state symbol क्या होगा? ये हमें पता है SnCl2. tin 2 chloride का क्या state symbol है यहाँ पर? It's aqueous, right? It's given in the question. Okay. And now we know that tin 4 chloride is also aqueous, right? They're saying a precipitate of Hg2Cl2 is produced. So that must be solid. Okay. Now, how many tins do I need for every mercury? Well, they've already balanced this for us. We need one of these, and if we have two of these mercuries here, we're gonna need 2 HgCl2. Right? Because इन्होंने हमें पहले से balance करके दिया हुआ है ये part. So we have 2 mercuries here, and we have 1 tin on both sides. All right. So that's the answer. All right. This question number 3. Over 1 million tons of hydrogen cyanide are produced each year using the Andrew-So process. The overall equation for the reaction is shown below. Okay. Draw a dot and cross diagram to represent the bonding in a molecule of NH3, ammonia, and state the shape of the molecule. Okay, so सबसे पहले अमोनिया में नाइट्रोजन के कितने आउटर इलेक्ट्रॉन्स होते हैं? नाइट्रोजन के कितने आउटर इलेक्ट्रॉन्स होते हैं? 3 नहीं होते, 5 होते हैं, right? It's group 15. So nitrogen, right? We're going to use an X to represent nitrogen and a dot for hydrogen. Okay. So nitrogen में क्या होता है? It makes 3 single bonds with the hydrogens, and then it has a lone pair. Yes, 3 bonded. Yes. So now over here, what's the shape of this molecule? It's making 3 single bonds and it has a lone pair. So the hybridization क्या होगी इसकी? इसकी hybridization must be sp3, right? And the shape is trigonal pyramidal. The shape is trigonal pyramidal. Yeah, 107 degrees. But they don't want you to draw the shape. They just want you to draw the dot and cross diagram and state the shape. Okay. So they're not asking for the bond angle or drawing the shape. Okay, a molecule of hydrogen cyanide is shown. The bonding between the carbon and the nitrogen atoms consists of 1 sigma and 2 pi bonds. Sketch the shape of the sigma bond and one of the pi bonds. Show clearly the position of the atomic nuclei in each diagram. Atomic nuclei in each diagram. So they're saying आपका जो C triple bond N है, इसमें से आप एक sigma bond बनाए और एक pi bond बनाए. अब पहले मुझे ये बताएं, तो जो आपके nuclei होते हैं, आपके जो nuclei होते हैं sigma bond में, let's say these are our 2 nuclei. Is the bond in the same line as the nucleus or above and below? Is the bond in the same line as the nucleus or is it above and below the nucleus? It's in the same line as the nucleus, right? So can I say that a sigma bond sort of looks like this when the 2 regions overlap between the nuclei, right? This is a simple way to represent it. You can also use the concept of orbitals, right? Like this, जो आप लोगों ने सीखा हुआ है. But the idea is that the 2 nuclei lie in the region of electron density between the bonds, right? That's one idea. What about a pi bond? Pi bond कहाँ पर होते हैं electrons? Above and below the nucleus, right? So if you guys remember, we've drawn this before in the class, right? So it's sort of like this, right? It's basically 2 p orbitals overlapping, right? And you can use the infinity sign also. You can also use the infinity sign. But the idea is that when the electrons, so this is what the overlap looks like, right? Right? Now, when these two overlap, what happens? When these two overlap, what happens? The region of electron density sort of becomes this guy, right? This is your region of electron density, agreed? Essentially, does that make sense, Mohammed? So that's once they overlap, the region of electron density looks like this. Okay. If you want to draw it simpler, you can literally just show it like this. You can literally just show it like this. The pi bond ki electron density is above and below the nuclei, like that. Okay, that's a simpler way to draw it. That's how you're going to find it in your marking schemes as well, if you ever look into it. Okay. So we can just, I'll just write it down over here. The dot over here represents the nucleus. And this is the electron density for a key. Just why not? Okay. Next we have part B. The reaction exists as a dynamic equilibrium. Explain what is meant by the term dynamic equilibrium. Dynamic equilibrium is achieved when the rate of the forward reaction, okay, is equal to the rate of the backward reaction. Okay, now this is for 1 mark, they'll accept this answer, but sometimes they'll ask the exact same question for 2 marks. So when is dynamic equilibrium achieved? It has to be achieved in a, what type of conditions do I need for dynamic equilibrium? It needs to be in a closed system, because we don't want factors to affect the position of the equilibrium, right? So closed system means that we keep conditions constant, temperature, pressure, volume, etc. So therefore we say in a closed system. State and explain how the amounts of chemicals present in the equilibrium mixture will change when the pressure is increased. So let's go back. When the pressure is increased, which side of the reaction will be favored? Pressure is increased. The left side will be favored, right? On the left, we have 1 plus 1 plus 1.5. We have 3.5 moles of gas. And on the right side, we have 1 plus 3, which is equal to 4 moles of gas. Now, if you guys remember, if I increase the pressure, the system wants to decrease the pressure. It decreases the pressure by reducing the number of moles of gas. So for every 4 moles of gas on the right, we'll produce 3.5 moles on the left. So it will decrease the pressure by shifting equilibrium to the left. That's Le Chartier's principle, right? So what will happen is state and explain. So we can say that the yield of products will decrease, right? Because since equilibrium shifts to the left, since the equilibrium shifts to the left, right? Because there are fewer moles of gas on the left-hand side. All right. The process uses a platinum catalyst, which increases the rate of reaction. Sketch a Boltzmann distribution on the axes given and use your diagram to explain how the platinum catalyst increases the rate of reaction. So first of all, Boltzmann distribution, where does it start? From the left-hand side. Does it start at the origin or does it start elsewhere? Where does the Boltzmann distribution start? Does it start from the origin? It does, right? Because 0 molecules have 0 energy. All molecules have some energy. So it will start from the origin, right? And then it's sort of an asymmetric distribution like this. Like that. You just have to sketch it out. Now, if I wanted to show the effect of a catalyst, what do I have to show on the diagram? I have to show the activation energy without the catalyst. Right? And I have to show the activation energy with the catalyst, which will be higher or lower. Obviously, with the catalyst, it will be lower. There we go. No, what do you mean higher? Roha, rate will be higher, activation energy तो कम हो जाएगी ना, molecules ज़्यादा होंगी ना above it. हाँ, वही मतलब था. Yes. So now we have to explain, use your diagram to explain how the platinum catalyst. So we can say that right? The catalyst lowers the activation energy, hence there are more molecules. Okay. Hence there are more molecules with energy greater than or equal to the activation energy, which means that what happens? Hence, so the frequency of successful collisions, right? We're going to have more successful collisions now because there's more molecules that have enough energy. So frequency of successful collisions increases. Okay. Awesome. If you look at the shaded area, only this many molecules had enough energy for reaction because you need minimum energy, activation energy चाहिए. So सिर्फ इतनी molecules थी. Catalyst add करने के बाद ये वाली molecules के पास भी enough energy थी. So can I say that adding a catalyst meant that more energies, there are more molecules with greater energy than the activation energy, since you've lowered the activation energy? Now there's more molecules present above the activation energy. So that means molecules, when they collide, reactions take place and they collide with enough energy. So can I say that there's more molecules that will collide with enough energy? So we can say that frequency of successful collisions increases. Okay. Yeah. The reaction of hydrogen cyanide with propanone is an important first step in many organic syntheses. Give the full name of the mechanism of this reaction. We have HCN reacting with a ketone. ये किस तरह की mechanism होती है? Anyone remember? This forms COH and CN. So this is nucleophilic addition. Right? So complete the diagram. Acha, my question is, does this cyanide ion, does it come from HCN or does it come from somewhere else? Where does the cyanide ion come from for this reaction? It comes from NaCN, it comes from the catalyst, remember? Or NaCN or KCN, because they ionize completely. So what we have here is, we have a delta positive and a delta negative. This nucleophile attacks that delta positive carbon and this bond breaks. So what we form is an anion intermediate, CH3, and now we've bonded the CN, right? What happens in the next part? This oxygen attacks what molecule? The HCN molecule, right? Here delta plus hai, here delta minus hai, and this bond breaks. So at the end of it all, what do we have? We have CO, addition of HCN, right? Addition of HCN, and the catalyst is regenerated. The catalyst is regenerated. All right. That was 5 marks for this. So that's, know your mechanisms. You might be able to score well on this. Okay. Question 4 starts on the next page. Now question number 4. The following compounds were all found to be components of a sample of petrol or gasoline. Give the molecular formula of compound G. What's the molecular formula of compound G? We have 1, 2, 3, 4 carbons. We have 4 carbons and it's a simple alkane. So it's C4H10. Give the empirical formula of compound H. Now compound H, again you have an alkane. And how many carbons do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have eight carbons, right? And I have 18 hydrogens, if you count. So what's the empirical formula? It's C4H9. The molecular is C8H18. The empirical is C4H9. Draw the skeletal formula of compound J. How do I draw the skeletal formula? First, just identify the main chain. I have a 3-carbon chain with an OH. So 1, 2, 3. That's your 3-carbon chain, right? यहाँ पर एक OH है. पहले कार्बन पे OH है और साथ साथ क्या है? पहले कार्बन पे OH के साथ साथ we also have a methyl group. So technically it becomes carbon number 2. This is carbon number 2. So this is carbon number 1. So here, this is your chain. This is your chain. So you have a 4-carbon chain essentially, right? And on carbon number 2, you have an OH, and on carbon number 3, you have another methyl group, just like that. Write an equation to represent the complete combustion. Write an equation to represent the complete combustion of compound H. So compound H की complete combustion क्या होगी? Again, we said we had C8H18. That was the molecular formula. For combustion reactions, you can use the molecular formula. So we'll just use the molecular formula, CH8H18. Okay, reacts with oxygen gas to produce carbon dioxide and water. Now, how many carbon dioxide will I produce? 8. How many waters? I have 18 hydrogens, so that will be 9. And then how many oxygens do I have? 8 times 2 is 16. 16 plus 9 is 25. So I need 25 oxygen atoms, which is 12.5. Half of 25 is 12.5. So I need 12.5 oxygen molecules. Yes, you can say 25. You can write in fractions as well, 25 over 2. That's fine. Okay. Fossil fuels are often contaminated with sulfur. State and explain why supplies of fossil fuels that contain sulfur pose a problem to the environment. So why do sulfur impurities, what do they produce? When you combust a fossil fuel and you have impurities, right? So yes, so we can say that combustion of sulfur, right, produces sulfur dioxide, which contributes to acid rain, right? So really it's sulfur dioxide that's the pollutant that causes acid rain eventually. The boiling points of compounds. Why does it say where does it say we combust fossil fuel? Well, what do we do? I mean, so that's a good question, Mohammed. What's in the name of the word fossil fuel? What's the second word in the name fossil fuel? Fuel, right? What do we do with fuel? Fuel को हम लोग oxidize करते हैं, combust करते हैं. That is what fuel is, right? So when we say fossil fuel, it means that we're combusting it. Does that make sense? Just like I say, when glucose is in your body, glucose is a fuel and it reacts with oxygen to produce carbon dioxide in respiration, right? So that's what we do to fuel, okay? So that's the idea. Now, next part. Boiling points of compounds G, H, and J are shown below. Explain the differences in boiling points of the 3 compounds. So J has the highest. Why does J have the highest boiling point? Why does J have the highest boiling point? Because it forms hydrogen bonds. It has this OH group, right? So we can say that J has the highest boiling point. Since it has, since it forms, since there are hydrogen bonds between molecules. Okay, which are stronger than van der Waals forces due to induced dipoles in G and H. Hence, more energy is needed to overcome them. More energy is needed. Make sure you talk about the energy needed since they're asking about boiling them to overcome them. Now, why is G so much smaller than H? They both have the same intermolecular forces. So why is G less than H, or H is greater than G? Number of electrons, right? Well, no, not branching. So ईशाल ब्रांचिंग से तो कम होता है, लेकिन एज का ज्यादा है यहाँ पर, राइट? अगर 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 जैसे 2 C8H18 होते हैं तो फिर ब्रांच वाले का कम होता है, कम ब्रांच वाले का ज्यादा होता है. यहाँ पर एज का ज्यादा है क्योंकि यहाँ सिर्फ 4 कार्बन है, यहाँ पर 8 है. सो यू हैव अ ग्रेटर नंबर ऑफ इलेक्ट्रॉन्स, राइट? सो वी कैन से दैट H has a higher boiling point. H is higher than J. H is higher than J because then not J, sorry, then G, because it has stronger van der Waals forces due to induced dipoles. Since it has a greater number of electrons, or more electrons. Okay. Compound J can be produced from 2-chloro-3-methylbutane. Compound J can be produced from 2-chloro-3-methylbutane. So let's draw this out. We have butane, so that's 4 carbons, right? And you have 2-chloro or 3-methyl, right? So let's call this carbon 2, carbon 3. So they're saying you can replace, this chlorine atom. You can replace this chlorine atom with an OH group. You can replace this chlorine atom with an OH group, right? So our product over here is this guy. So how do I do this? Give the reagents and conditions. I use NaOH aqueous and heat under reflux. This is nucleophilic substitution, hydrolysis of halogenoalkanes. NaOH aqueous and heat under reflux. Okay. There we go. Last question, question number 5. Some reactions of compound P, C5H8O are shown. Compound P, give the structures for organic compounds Q, R, S, and T. Okay, so when I use hydrogen and nickel, what will it reduce? Hydrogen and nickel किस चीज को reduce करेगा? It should reduce alkene to reduce करेगा ही. It will also reduce what? Hydrogen and nickel.
The ketone.
The ketone. अच्छा, now one thing I want to mention over here guys is that जो एग्जामिनर रिपोर्ट है ना इस क्वेश्चन के लिए इसके मार्किंग स्कीम में कीटोन को रिड्यूस नहीं किया था, और एग्जामिनर रिपोर्ट ने बोला कि बच्चों को पता होना चाहिए कि एल्कीन रिड्यूस करेगा और कीटोन रिड्यूस नहीं करेगा, सही है। लेकिन इसी सवाल ऐसा ही एक और सवाल आया था पहले, इसमें एग्जामिनर रिपोर्ट ने कंप्लेन की थी कि बच्चे को क्यों नहीं पता कि दोनों चीजें रिड्यूस करेगा। यानी कि एग्जामिनर जो है उसने पहले बोला, उसने एक बार ये बोला कि भाई बच्चों को पता होना चाहिए दोनों चीजें रिड्यूस करेगा, और एक बार बोला उसको पता होना चाहिए सिर्फ एक चीज को रिड्यूस करेगा। The fact, however, if you guys want to know, is that hydrogen and nickel does reduce a ketone. Okay, hydrogen and nickel does reduce a ketone, so that's the correct chemistry. All right, I just want to clarify this. Yes, I know we've done this in class, but I just want to clarify. Okay, hydrogen and nickel will reduce a ketone. Okay, as far as the correct chemistry is concerned. So what's the structure gonna be? Like that, and then the ketone becomes an OH group, and the alkene obviously just becomes an alkane. All right, so we have a secondary alkene. All right, cold dilute acidified KMnO4 to form compound S. तो S का क्या स्ट्रक्चर होगा? कोल्ड डाइल्यूट KMnO4 से क्या होता है?
weak oxidation.
वीक ऑक्सीडेशन, तो डायॉल बनती है, राइट? दो OH ग्रुप लग जाती हैं। सो व्हाट वी हैव इज, कीटोन को तो कुछ नहीं होगा इसमें ऑब्वियसली, लेकिन आपके जो डबल बॉन्ड था वहां पर दो OH ग्रुप लग जाएंगे। Make sure you show it bonded nice and clearly to the oxygen atom. There you go. What about R? R में we're using NaBH4. Now NaBH4 सिर्फ किस चीज को रिड्यूस करेगी? सिर्फ कीटोन को रिड्यूस करेगी, but not the alkene. Alkenes के लिए सिर्फ हाइड्रोजन एंड निकल चलता है हमारे सिलेबस में, सही है? So we say that this guy over here will reduce the ketone, but not the alkene. Right? So this will become a secondary alcohol. All right, and the last one is we're using sodium iodine and alkaline medium. So this is the iodoform reaction. So we're forming compound T plus the salt of the carboxylic acid. Now if you notice, यहाँ पर एक कार्बन कम हो गया, एक कार्बन कम हो गया. What's that compound that we form when we break off this carbon? इस कार्बन से क्या compound बनता है, किसी को याद है? CHI3. This is called triiodomethane. This is called triiodomethane. Okay, so I like the skeletal for this. It's just this. It's a carbon atom bonded to 3 iodines. Okay, and obviously the hydrogen isn't shown here. The hydrogen isn't shown here. So this is CHI3. Again, you don't have to draw the skeletal. You can also draw any type of structure since they haven't specified. Okay. All right. Give the systematic name of compound P. What is compound P over here? Compound P का नाम क्या है? Let's see. It's okay. So it's 1, 2, 3, 4, 5 carbon atoms. 1, 2, 3, 4, 5. So it's pent. Now, what gets higher priority in numbering? Will it be the ketone or the alkene? What will get priority in numbering? The ketone, right? It comes right at the end of the name. So we can say that the ketone gets priority. So that means this is carbon number 1, 2, 3, 4, 5. So then the double bond is on what carbon number? The double bond is on carbon number 3. So we can say it's pent 3 in En and then 2 on. Pent 3 in 2 on. Okay, so that's the name. That's the name. Yes. अच्छा, when जब यहाँ पर कीटोन बाद में आता है, you remove the E. Okay, it's ENE के बजाय it just becomes EN. जिस तरह से पेंटन बनता है ना, पेंटेन नहीं होता ना, पेंटेनोन होता है ना, जिस तरह से पेंटीनोन हो जाते, E हट जाता है इससे, सही है मोहम्मद? Yeah. what would you observe when compound P is reacted with 2,4-DNPH? So compound P has a ketone. No, not the alkene isn't given priority, na? The ketone is given priority. Numbering देखो ना हमने कहाँ से की है, मोहसिन. Ketone को lower number assign किया है ना? Yeah. So ketones and aldehydes with 2,4-DNPH, they give a bright orange precipitate. So we can just say an orange precipitate. Okay. Orange precipitate. All right. Last part. The last part over here says compound U contains a chiral center and has the same molecular formula as compound P. So compound U is also C5H8O. Compound U readily decolorizes a sample of bromine water. Okay, so it decolorizes bromine. It does not show cis-trans isomerism. Okay. And when compound U is heated under reflux in the presence of excess acidified dichromate, the organic product gives the infrared spectrum shown. So they're saying कि compound U को जब आप oxidize करते हो, जब आप compound U को oxidize करते हो, you get this spectrum. You get this spectrum. When you oxidize compound U, you get this following infrared spectrum from the product. Okay. So this is the product of the oxidation of compound U. Use the information given to suggest a structure for compound U. Use the infrared spectrum given to suggest a structure for compound U. Okay. Now this is a difficult question, guys, and this question was actually removed from the grading of this paper, but we'll try to solve it anyways. Okay. Now, my first question is this. Yeah. So my first question is this. Okay, if compound U decolorizes bromine, if this guy decolorizes bromine, right? First of all, what type of a group does it have? Alkene group. Yes. So it has an alkene. Compound U में alkene है. यहाँ तक हमने पक्का confirm बात है, confirm. सही है. अच्छा, अब दूसरी बात इन्होंने बताई हमें कि compound U जो है, it doesn't show cis-trans isomerism. So where could the alkene be? Can I say that the alkene is most likely a CH2? Most likely a CH2. As just as a possibility. Right now we're just looking at possibilities. Right? कि पहले एक carbon, शुरू वाले carbon पे क्या है? Alkene. सही है? Now, the next part of the question says कि when compound U is heated under reflux in the presence of dichromate, the organic product gives the infrared spectrum shown. Now, if you guys notice here, they're saying that this is an OH group from acid. Do you guys remember? If you guys look at the data booklet, this very broad OH peak, comes from carboxylic acid, right? So what group would oxidize to form a carboxylic acid with dichromate? What group would oxidize to form a carboxylic acid with dichromate? अगर carboxylic acid बन रही है, तो carboxylic acid जो है वो यहाँ पर बनी, right? तो यहाँ पर कौन सी group present होगी? Aldehyde या फिर primary alcohol. Agreed? So this guy was formed from either an aldehyde or a primary alcohol. Right? That's what formed the carboxylic acid. Now, can I say that it must be a primary, it must be an aldehyde? Why can I say it must be an aldehyde? Because अगर आप देखें तो hydrogen atoms बहुत कम है. Hydrogen, there's a, well, this, no. See, so let me actually rephrase this question. Okay. What we know over here is, so we know already that compound, this is compound U. Now we know हमारे product के अंदर C double bond OOH है हमारे product में. सही है? Now if you notice, हमारे ये जो C डबल बॉन्ड O की पीक आ रही है, ये जो C डबल बॉन्ड O की पीक आ रही है, ये तो एसिड से आ रही है। ये जो C डबल बॉन्ड O की पीक आ रही है, ये तो प्रोडक्ट से आ रही है। हमें रिएक्टेंट का नहीं पता। Reactant could have been, it could have been a CHO or it could have been a CH2OH. Okay? It could have been a CHO or it could have been a CH2OH. Agreed? Sahi hai? Now my question is this, that if it was a CH2OH, can I say I'll have 10 hydrogen atoms? I'll have a total of 10 hydrogen atoms. Agreed? But it can't have 10. The question says that the molecular formula is C5H8O. So there's fewer than 10 hydrogen atoms. So it can't be a primary alcohol. It must be what? It must be what? An aldehyde. Okay, it must be an aldehyde, yes. Now that's one thing. So now we fulfilled these conditions. It decolorizes bromine water. It does not show cis-trans isomerism, and the product is a carboxylic acid. Now they've also said that it contains a chiral center. Now, if it contains a chiral center, can it be a straight chain or must it be branched? It has to be branched, right? It has to be branched. So I can say, okay, that over here, I have a double bond. Okay, I have a double bond. And then I have a CH3 over here, okay, and an H and a C double bond OH. So this is the aldehyde group that we already identified, right? It has this alkene that doesn't show cis-trans, and it has a chiral center. So it's a 5-carbon compound that fulfills all of the conditions given to us.